we at Tethys Robotics developed this next generation underwater drone, which focuses on compactness. Thanks to our software solution, we can not only localize the robot under any conditions, but also map the environment. So this gives the robot very autonomous capabilities, so it can move and operate where it's aware of the terrain around it. So it can operate for one side for within the public sector for search and rescue operations, and on the other side, we look in the industrial inspection sector with a very much focus on renewable energy. You have two options. Either you have a pilot operating the thing, so you have a VR-enabled user interface in that regard. So you have both basically visual information and acoustic information displayed as a 3D map in real time for the operator. Or of course, if you have an autonomous interface, it's much simpler. You just say, well, we need to search that area or inspect that kind of structure, and it does it for you, basically. So we focus really on the most challenging conditions. So here in Switzerland, for example, we have rivers, which are quite challenging to operate in as humans or as any other solution that's currently out on the market. So that's not really possible. So there are no solutions for high currents, if you want so. Similar problems there are also offshore for example, the tidal currents when you want to operate near these offshore wind farms and so on. So it's quite comparable problems we look at currently. If you come from aerial drone where you can apply standard visual feature detection based on cameras, we tried the same solution basically, but on acoustic sensors, which is not directly transferable. And therefore, we have now built an AI-powered pipeline to have still a feature detector, but on acoustic sensors like a sonar, for example.